So we're given rhenium has two naturally occurring isotopes, 185 and 187. It's given us the average atomic mass of both of them, the weighted average, and it gives us all the information about 187. It gives us the mass and its percent abundance. Right, and with all that information, we're asked to calculate the mass of the other isotope, rhenium 185. All right, so we can do this. It's going to require a little bit of algebra, but we'll use this formula here where we take the mass of the first isotope, multiply by its percent abundance, and we're going to add that to the mass of the second isotope, multiply by its percent abundance, add that to the so on and so on and so on, and you get what we call the atomic mass, which is the weighted average of all the isotopes. Now, typical of a problem where we give you the atomic mass and ask you to solve for one of these, it's almost always going to be two isotopes because the math otherwise gets pretty hairy. All right, so that's what we have here. We only have two isotopes. So we'll get rid of this stuff. All right, let's just plug and play here and do a little algebra and get our answer. Let's do rhenium 187 is what we're given. We'll just make that here in light blue. We got the percent there, we got the mass there. We're going to plug that in right there as M1 and P1. All right, so the mass is 186.956. All right, let me put my units on there. And multiply that by the percent is, now I'm going to turn this percent into a decimal form by moving the decimal over 2 times. That'll get rid of the percent. You can use your percent function if you want on your calculator. I prefer using decimal forms, 6260. All right, and the mass of the second isotope is what we're looking for. Let's just call that X, or you can call it M2. And then the percent, since there's only two isotopes, the two have to add up to 100%, or 1. Right, so that plus whatever we got there is going to add up to 1, because 1 is 100%. 100% decimal form is 1. All right, let's just get that out of the way now. All right, so if you add up that plus that, you get 1. Or 37.4% plus 62.6% is 100%. All right, all that equals the atomic mass, which was given to us in the problem. There it is. We can do a little simplification. You know what? I'm just going to do all this in my calculator. There's a lot of writing. All right, here we go. Let's simplify. Do this 0.956 times 0.626. All right, so I don't feel like writing all that. All right, I better write it out. 117.03. 117.03. There's more numbers to it, but I have it stored in my calculator. All right, and that is going to equal, or that plus, right, 0.3740x is going to equal that number to the right. Now let's subtract both sides by 117.03. All right, I've got the stored number, so I'm always going to use that. All right, so 186.207 minus my stored numbers. That's the better number. All right, so 6917. 6917 is what I have on the right side, and on the left side I still have that 0.3740x. Let's isolate x. All right, we got x. That's going to be our answer. All right, grab that number from above, divided by 3740. So the mass of the rhenium 185 is right there on the screen. 184.95. 184.95. All right, sig figs. They're not following sig fig rules, so we don't have to. Now, if we gave you this kind of problem on the test, we would tell you, why don't we use 3 decimals? Because that's what that they're using that on all the other 2 examples. So I think it was 953. All right, so there's our answer. But I know they're not using following sig fig rules because if you, for example, if you did that, all right, that has 4 sig figs, you would not get that. So that's how I know right away. So on our test, we'll tell you on these kind of problems where we give you the atomic mass and we give you this stuff and we ask you to find one of these, we'll tell you just give your answer, express your answer to like 3 decimals or 6 significant figures. We'll tell you that.